Hello and welcome to the beta release 0.1.10 of Onyx. This is a really exciting release, and I'm just going to get right into these changes because there's kind of a lot to go through and a lot of demos to give. So, the major change in this release is JavaScript Interop. Onyx's JavaScript story before this was really quite sad. As much as Onyx only targets WebAssembly, it was not easy to use from the browser, and so that was kind of not great to say the least. So now Onyx features like first class JavaScript interop that you don't have to do anything hacky to work with. It's supported by the toolchain and the compiler, and so it's really easy to use. And so just to give a brief explanation of how some of it works, basically there's this new directive in the language called #JS, and what you do is you give it either a raw JavaScript source code like string, or more likely you'll give it a file that will be loaded. And what the compiler will do with these JS directives is it will take all of this JavaScript code that you provided in these files and in these strings, and it will concatenate them all together in a specified order, and then it will write them to a separate file during the compilation. And so actually in your compilation, you'll get two files out. Instead of just the WebAssembly file, you'll also get the WebAssembly.js file. And that file can be used to load the WebAssembly file and actually get it running without much code from you, which is a huge win. So, as I kind of mentioned, these JS directives will compile all the source code, like their strings and file contents together in the specified order, and that order is determined by you. You can specify the order by simply placing the order here. Now, this is actually, I need to update this example because this is actually wrong. The actual way that you specify it, if I look at how it's defined in the core library, is you have to use the #order directive. And then this will tell it the order to place this JavaScript source code into the big JavaScript file. By default, the order of everything is like int max, and so everything is just equal precedence at the end. And so if you specify an order, it's going to be before any of those other things. And this Onyx.js file is really important, and so it has order 0. It is the first thing that's always loaded, and you should probably not use order 0 because you don't want the random sorting of equal things to happen to be where your code is going to happen before this one, because this is a really important file. I'm not going to go through everything in this file, but it defines all of the interop of how Onyx can interact with JavaScript objects, JavaScript arrays, all these things through this like JavaScript heap, which stores JavaScript objects and lets Onyx access them, to this syscall module that is the actual functions that Onyx will call to interoperate with these things, right? So this needs to be loaded first, and so it has order 0, and any other module should come after it. But you will likely not need to use this because this is more for library authors and people just kind of working and adding things to this. You will likely just be able to use the other big feature that was added, which is the code. Wow, this says code.js. Wow, I really just need to update all of this. The core.js package. So the core.js package is a new JavaScript package that was very inspired by Go's syscall.js. And so if I go look at that, basically what it does is it's a very thin wrapper on top of JavaScript objects and values. So you're able to do things like invoke a procedure or call a method on an object, or create a new object using the new keyword in the language, right? And so that's super important to be able to do. And so I basically I re-implemented this idea, but in Onyx. And so all of the really cool features of how it works, that's all up to thanks to the Go team. So I cannot claim any of that, but I used it as a huge inspiration. So here's a little simple demo that creates a button on a page, and when it is clicked, it alerts a new message on the page. So as you can see, we're just using that core.js library. And if you squint, it kind of looks like JavaScript. Like if you don't think about it too hard, there's some JavaScript in here, right? So we're getting the document, right? js.global is basically the window object when you're dealing with a browser-based JavaScript engine, and it's the global this object when you're dealing with Node. And Node might actually have a different name for it as well, but basically it's the special global that contains all of the top level symbols. And so that's why I called it global instead of window. You could define an alias that says window is just global if you wanted to make that clearer. But anyway, we're getting the document just like you'd say window.document on JavaScript. We're then calling the create element method on the document and passing in the string button, which is of course going to make a button element on the page. We're then setting the inner HTML property to be click me. So set is basically equivalent to just like dot inner HTML equals click me. It's just a little, obviously we can't write that in Onyx, so you have to go through a function. So that's what set does. Call, I think you can figure out, we're calling the method add event listener, and we're passing in these arguments. So just like in JavaScript, we have to pass in 2 arguments. Click is the name of the event. And then the really cool thing is that you're able to pass an Onyx function as a callback to a JavaScript event or just to anything to JavaScript. And you do that by simply wrapping this in this js.func, which will take your procedure that has to be of a particular type, and it will wrap it in a JavaScript function that is just going to call your Onyx function. So what this is doing is it has to take in 2 arguments, which is the this value, right? So remember, any JavaScript function has an implicit argument called this. Even if it's just a normal function, it'll have a this of null. So we have to take in the this, and then there's a slice of arguments, which is just, as you'd think, it's just an array of arguments that are all JS values. And then it has to also return a value. And so remember, in JavaScript, implicitly, if you don't return anything, it returns undefined. In Onyx, you have to do that explicitly because every one of these functions has to return something. So you just have to return js.undefined. So in this function, all we're doing is calling the alert function on the global, which of course is like window.alert. And that's going to make a message pop up that says hello from Onyx. And then to end it off, we're getting the body of the page and we're calling the append child function on the body and passing in our button, right? Again, if you squint, like this is not very far off from what the JavaScript for this would be. To actually use this on your page, you can just include this bit of JavaScript. Basically what it's doing is it's using ES6 modules, but we should be able to get around that. Right now, the actual, that's the wrong button. The actual JavaScript source code in here is written in an ES module fashion with an export default and everything like that. This could probably be changed and like lowered down to like ES5, but I don't know the overlap of browsers that support ES6 and browsers that support WebAssembly. If, you know, I don't necessarily want to cater to IE11. I don't think Onyx is really going to be used in a situation where that is a concern. So, it might be worth making this not ES6, but for right now, it is. And so you can use Onyx just in this way, just using import. You can import that Onyx object from there, and then you can call the static method load on it. You pass in basically the path to that WASM file, and that's going to return a promise that gives you the actual instance, and then from there you can call start, and that will actually start your code. It will call the _start function, which in turn will call main and do all of those things. You might be wondering, why do I have to specify this, right? Why can't the compiler just do this for me? Well, it could, but the problem is that I don't know how your JavaScript and like hosting situation for all of this is going to work out, right? I don't know where you're going to put your JavaScript file, your WASM file. You might want to keep these together. You might want to separate them. Is it always going to be in the same folder, right? I don't want to have to deal with any of that weirdness. So I'm just saying you have to know the name of both of these, right? And that just made things a little bit easier when designing the system. And then, yeah, to compile this, we can just use the RJS flag when we build, and we'll get an outwasm and an outwasm.js. And so let's just see this and make sure that this works. So the other thing I'm going to demo, because it's kind of fun, I don't think it's the next point, somewhere down here, is this Revamped CLI. So the CLI got a major facelift in this update. We have colors, and we have shorthand commands, and just a lot of better things. It makes Onyx feel a lot more polished, right? Onyx is always striving for a great developer experience. I think that's one of the things that Onyx will specialize in, and why it will be chosen over other languages potentially is because of its developer experience. And so while it's a small thing to mention, like, it goes a long way. And so I'm going to start by making just a new project so I can use the Onyx new command. And I actually don't want to do it that way, because if I run it like that, it's going to make a new one in this folder. I want to make a new one using the default template, and I'm just going to call it JS Demo. Right? And so I can call it JS Demo. Right? Go into JS Demo, and I know I mistyped this. This just fills out the package file, which if you're not going to publish this anywhere, it doesn't even matter. So if I go in here and I look at the source code, right, we can see that we have this file, and it should run and compile and do all the good things. So let's make this actually that code from the website. So let's go back up here and copy this. All right. So of course the LSP is now complaining. It's like, hey, I don't know what any of this is. And we could fix that by going in here, and there's a new flag on the LSP that you can say what the runtime is. You can say I'm going to be using the JS runtime. I think there's also, I forget all the LSP configuration things, but I think there's a way to pass args as well, and you could say args JS, like RJS, but I think this is true. So you could do this, but there's also just a more canonical way to just say we're using the JS runtime. Of course, we have to restart the LSP because it's not going to just do that for us. Well, not yet. The LSP needs a lot of work, but we can do that, so now it's all happy. I'm not going to change this code at all. I'm just going to pop open in here, and I'm going to Onyx build RJS, that source main. So now, as you can see, we have that WASM file and that JS file. And if I look at that JS file, you'll see it's basically just the contents of that file we were looking at before, because that's all that was there to paste into it, right? Okay, so now we have to make some other things. We have to make basically an index.html file that we're going to host this out of. So let's do that. Let's create an index.html. Let's use good old snippets to make this. I don't have a CSS file. Let's call this demo. We're not going to put anything in the body because that's what our script should do. And let's copy this script code. Make sure that this all works. All right, and now if I were to run a local server out of this folder, and I go to localhost 8000, I think is the default. Oh, this is a good sign. We have a button that says "Click Me," and I honestly don't think I can zoom in any further. So I've got a "Click Me" button, and when I click it, it's really small on my screen, and I can't make it any bigger. But it says "Hello" from Onyx, and so that's what we were looking for. And so all of that code was all from Onyx, of course. So, you know, just to prove this is all working, we could say document, let's get the body, and let's set on the body its style to be, I forget how to do this. Can you just say this? You know, it's been such a long time since I've actually done anything in JavaScript land. No, you cannot just say that. There's some way to change the style, but I forget this might have to be an object, but I'm not going to dwell on that. It does work. Right, all of this is going through Onyx. So, you know, I could instead of saying "click me," just to show this is actually live, I could say "click me" with a lot of exclamation points. Terrible at coming up with examples, but come in here, refresh this, "click me" with a lot of exclamation points. So this is all happening from Onyx, and it's just using this thin wrapper layer that allows Onyx to interact with JavaScript objects. And I can do a longer video explaining how that system all works. But if you are familiar with how Go's syscall.js library works, it is very similar, because I thought they just did a great job, and no sense in completely reinventing the wheel, because I would have ended up with something really close to what they did. So that's the JavaScript Interop. It is really fun. So this is a really simple thing so far, right? You're kind of doing things raw using these strings, which is of course error prone. If you misspell one of these things, you're not really any safer than using JavaScript directly, and I understand that. But what this enables the Onyx community to do now is to develop wrappers around certain JavaScript APIs that are, of course, really useful. So like the DOM, for example, right? Probably shouldn't need to say, get the document from the window. We probably should just be able to say, hey, give me the document, like just window.document, and have a create element method on document and not have to go through this call, right? And so, well, a lot of that would just be like wrapper code around all of this. It would significantly help, I guess. It would make it more type safe. And so that's something that I'm hoping that people want to work on, and that's something that people definitely can contribute to. One thing that I wanted, and so I made in this vein, is WebGL2 bindings. And so I just have a a big old file here. Go read through it, but they're just linking to these WebGL2 bindings. And of course, at the top here, it has a JS file directive, and then this is the JS file that just has all of the WebGL2 wrappings that work at a little bit more of a lower level, so you don't have to deal with all of these like get and call, because you could do this by hand too. You could say, context arrow call, create array, or create vertex array, or create buffer, I think is what I'm trying to think of. But you could do that, but of course it's going to be more error prone. And so having that wrapper is going to be a little bit nicer. And so if there was a similar wrapper to WebSockets and to the DOM, and just everything else like that, that would be a great thing for Onyx to have. So this is really exciting for Onyx. I think it's going to push in a new direction, and it's going to make these kind of programs just so much easier. So this is an awesome thing. I'm really excited to have this. The next one is kind of an interesting change that I made a couple weeks ago, but I have no regrets removing it. So basically in Onyx, there is this directive called inject. And so directives in Onyx, just to preface that, are like keywords, except I didn't want to dedicate a whole special keyword to it. And so you have to put this pound sign in front of it to say, this is a special word that's following this, and the parser will know that. And so the parser will know when to parse these different directives, right? Just like JS. I mean, I kind of just glanced over it, but this is a directive, right? I didn't want JS to be a keyword in the language, but I wanted you to be able to say pound JS to reference that stuff. So they're like special, not keyword keywords, basically. And what I realized while using Onyx was that I used inject all the time. And that's simply because it was so useful. What you do with inject, just to give an example, is if I have like a structure, call it foo, and maybe it has some kind of name in it, just to have a simple example, you can put methods on structures or unions or anything, and you just do it by putting in a function just directly in their body, right? So you can say hello, and this is going to take a self, that's a pointer to foo, and I can have it say printf, which is not something I currently import, but I can say printf, I don't know, hi from formatted argument, that's just going to be self.name, right? And so I could call this, but basically this is a method on foo. But this gets really kind of clunky, and I don't love mixing the implementation details like these with the data definitions like these. And so while you can do this because it was super easy for me to add this, I don't love writing it this way. Instead, the way that I like writing it is like this. So let me format this a little bit. So what you can say, or at least what you used to have to say, was, hey, I'm going to take this say hello function, and I'm going to inject it into foo's scope, and basically make it as though I typed say hello in the scope of foo, inside of the structure. And so that way you could just define methods as like extensions onto foo. And the really powerful thing about this is that this does not have to occur right next to the definition of foo or anything like that. This could occur 5 files away. This could occur in a library written 5 years later, right? That adds on a method or extra functionality to a type, and the writer of that type doesn't need to care about that. And so I ended up writing a whole bunch of code that looked like this, right? I would have just these lines of inject. Or I would use the block form, which you could basically say inject into foo, and then you'd have all of these things that you could inject kind of this way, right? And what I realized, I'm like, this is such a common thing. I shouldn't have to say inject. Like, this should just be how the language works. And so that's what I did. You no longer have to say inject in front of these definitions. You can just write them as though you're just doing a binding inside of foo. And so the term inject will kind of live on for just a little while in the lingo, but what this is doing is just defining say hello inside of foo. So you can call it like extension methods, you can call it whatever you want, but the idea is this, that you're putting this binding inside of foo. And it removes just this whole weird keyword that you need to use for something that is so common. This does remove the block syntax, so there's no equivalent right now of this, which I think is okay, because this adds an extra level of indentation that's a little, I don't know, I find it a little annoying, and so maybe it's worth not having this extra indentation and just keeping things really the same by just always having things left aligned for all procedure definitions. But maybe there's a way I can get the syntax to work without needing to require the inject keyword. I think this by itself seems a little weird, just saying foo like this, but technically this isn't like, this is unique syntax. There's nothing in the language that lets you say, you know, any expression and then an immediate open curly brace in the top level of a file. So this could be valid syntax, but I think I like, for now at least, doing it this explicit way every time. And so that's what the deprecation of inject really means. Inject is still in the language, but you don't need to use it. You can just attach these things onto these structures. And so basically without it, so there's no equivalent of the block form, and you have to define everything. But I just think it's a lot cleaner without it. Inject will be removed entirely in a future release, but I'm going to keep it around for probably this release and probably the next one at least, because I know that there are still code bases and packages that I'm using actively that are still using it, and so I have to go through and clean those all up to get it removed. But I've tried it out in several different packages. Can I just delete the inject keyword, and it always works, and so it's really nice. So this has kind of become more of a staple of the language, that what you'll do is you'll define your type, and then you'll define your methods as just extensions onto that type. And speaking of that, this is now how arrays and slices work. So arrays and slices before were kind of weird in the language. Because they were special built-in types, right, that have special syntax, they were not given a scope like a structure, right? So if I hop over here, I quit out of all this, and I go into my Onyx code, and I close out of these things, right, if I look at map, right, which is the hash map implementation in Onyx, right, you can actually just go look at this, right? Map is generic for all types, and you can just go read the source code of it and, you know, see exactly what it's doing. And so you can see that, you know, map's just a structure, and it does all these things. And then down here, there's all these methods on maps, right? There's like map.init, there's map.free, map.copy, map put, has, get, and all those things. And so you could look at those, you could see that these are all just methods on top of map. And you could do these in sort of injections, is what they used to be, but now they're just like putting the binding on the map, because map's a structure, and that's something that you can inject onto. The problem is, with arrays, that used to not be the case, right? Arrays were the special syntax, you know, they look like this, right? This is a dynamic array, and this is a slice. And because I have this special syntax, there was nothing you could inject onto, right? I could have let you write the cursed syntax of, like, this, but I didn't think that was worth trying to make the parser parse. And so I decided I'm not going to do that. But now there are actual types for slices and arrays. So if I go into, actually go into built-in, there are now types. Oh, if I can type array. So there are now types for slices and arrays. So these structures represent the struct types. They are not the actual implementation details of these, right? Slices are now not, like when you write this, it is not exactly equivalent to slice of I32. There are still like internal details that are different in the compiler. Maybe one day I will like unify these two things, but for right now, slice and array represent the scopes behind slices and dynamic arrays, respectively. And so anything that you inject or just place methods onto array or slice are now available as methods on dynamic arrays and slices. And so we can go look at core array, core container array. And you can see now that all of this is written in this style, right? Where we're putting these methods on arrays. And that means that we can now use the arrow syntax, the method syntax, with dynamic arrays and slices. And so this is really cool. It just adds a whole nother level of like unification to the language, because before I would use the method call syntax with hash maps and like IO readers and all of these things. But then when I used arrays, I had to use the core.array library that contained all the array methods. And it was like these weird mixing of styles, and I just didn't really love that. Now you can use array arrow push directly as a method without having to worry about it. And so that's really cool. And then if you want to still use the old way, the preferred way is to now use the capital A array type and then use the methods inside of it. To not break a ton of backwards compatibility, there are all the definitions that used to be in the core.array library, but they are now just defined as aliases to the core or the actual array methods. So you can still write all the same code, right? This A right here, for example, could be lowercase, but if you made this lowercase, you'd have to use core.array. But because capital A array is a type that exists in the built-in file, everything in built-in is always accessible. And so this is now like a very core type to Onyx. And so this is really cool. And so just these changes in general represent like a larger move towards stabilizing and standardizing the pattern that you place the important procedures directly on the type using this indirect binding sort of syntax, and you place them on the type scope. That way, the consumer of your library or your type can choose to either call it as a method, right, where you just use the arrow syntax that will kind of rearrange into being this, or you can write the standard procedure way as well, using the type name as the prefix. And so I like the way that this looks, and it just feels a lot more standardized. Right now, you can do this with dynamic arrays, slices, hash maps, strings, all these things. One that I didn't even mention, but it is now the case, is that strings are also now written in this way. And so strings, more specifically a slice of U8s, now have a bunch of special methods that only apply to a slice of U8. And so when you have a slice of U8, you're using all the string methods, and so you can now, I think I have a test case for it, arrays with methods. String methods, if I can even spell. So you can now like say arrow copy, 2 lowercase, 2 dynamic string, append hello world, right? Or append world, whatever, right? You can write these, and it's a lot cleaner than having to import the string package. So, but of course, just like dynamic arrays, you can still use all the same string dot whatever, but it should now be preferred that you use like the type name or just using the arrow syntax to convert it. So, these are kind of the big changes in Onyx that do not break anything with backwards compatibility, at least as far as I'm aware, but they do kind of shift the language in I think, a better direction that is more uniform, that uses kind of the same syntax everywhere for everything. So, let's talk about some minor syntax additions now. So one experimental feature that I kind of wanted to try, and this I think will be around for a couple of releases if people like it. If nobody likes it and they think it's a bad idea, I will remove it because I'm kind of on the fence with it. But the feature I'm calling auto-disposing locals, which I'm still working on the name, I don't love it. But the idea is that the pattern of allocating a resource and then on the next line immediately deferring the free of that resource is so common. So let's just take this example right here. Right here, I'm making a dynamic array of I32s. And if I was a good citizen, I would have written defer the delete of this array, right? Which basically will call the delete on this, which eventually will end up being this built-in.delete function, which will free the array, right? And so that's a really common pattern that you do, is just defer the deleting or the freeing or the closing or whatever of a resource on the next line. But like I did here, it's kind of easy to forget that. And also, you know, these kind of lines come in a lot of pairs, right? So I'd like make a dynamic array, and then maybe I'd open a file and defer closing the file. And then I would make an IO writer and then defer closing the IO writer, and all of these things. And I decided, well, that's such a common pattern. Why not just make it easier to use with keyword? And so now, if you put the use keyword in front of a variable declaration, right? So it has to be the declaration with the colon in it. If you do that, this variable will be marked as auto-disposing, and what it will do is it will automatically insert a deferred call. So by writing this, it's like it's inserting this line of code. It's inserting a deferred call to this built-in function called dispose used local. And it passes in a pointer to your local, right? So that's exactly what it's doing. It's passing in a pointer to this local. Now this dispose used local is an overloadable function. If I go look at the code, so it is an overloadable function that must return void because you shouldn't use the result of it. But what you can do is you can overload this to define how you want to dispose of your thing. You'll see that it by default has a low priority, right? That's what the high order number is, a low priority definition for delete. And so when you want to just call delete on something, you can just use it, and delete will be one of the overloads, if that makes any sense, right? Basically, you don't have to like define your thing for delete and for dispose use local. You can just define it for delete, and dispose use local will just use the delete implementation. And so for most things, delete just gets it, you kind of get it for free, right? With like arrays here, because it defines how to delete it, you can just get that for free. But the kind of interesting one is like IO file, IO.os.file. It defines an overload for it that simply closes the file, right? So it just has this macro, and so you don't even incur any extra cost. It just defers calling the close function on the file. And so it's really, I don't know, it's really nice. I think it cleans up a lot of code. I just want to make sure it doesn't make it like too unclear about how certain things are working. It was inspired by C#'s using keyword, and I know there are other languages that have done a similar thing. I guess Python has their with blocks and other things, but I saw C#'s use of it where you don't have to make a new block for it. You just using, and then at the close of this block, it will free it. And I kind of really liked that. And so I wanted to see if that was something I'd want to do. So that's an experimental feature, but I think it's kind of neat, and I'll see how it plays out. And one other small but very useful thing is the inclusive range operator. So there's now the inclusive range, which is ... equals, and basically what this does is it is equivalent to just writing the range operator and adding 1 to the right-hand side. And when I say equivalent, I do mean equivalent. If I go here to the source code and let it all load, it's a little fuzzy, but you can read it. If the range is inclusive, make the literal 1, make a binary operator of adding the high number plus 1, set that to be the new high, and then check that. Right? Pretty straightforward. And so that's all this is doing for you, but it is really nice because sometimes you do want inclusive loops, and you don't want to have to write that +1 because it gets a little ugly. Another thing I should just mention about ranges is that ranges are now a little bit better in that they can now support 64-bit integers on the ends. So this is done by having a new type in the language called the range 64 type. So range is the old one that only supports I32s. There's now range 32, which is just the alias of range. So you can write range 32 if you want to be explicit. But there's also range 64, which, as the name suggests, is a 64-bit range, and it's used whenever either side of the expression is a 64-bit number. So in this case, because x is 64-bit, the type of this thing would be a range 64. And so you could see here how I'm creating a range from 0 to x, and then filtering over it, and it just supports it. And so that's pretty cool. And then the same thing here, I can just say for x dot equals, this is that inclusive range, basically from 10 up to 15, including 15, just print out the iterator, right? So it's a small thing, but it does really help with for loops, right? You get rid of a lot of casts. Because in my head, I'm like, why would anyone ever want to have a 64-bit loop, right? That you're looping over billions of things then. But that really wasn't the right way to think about it. The right way to think about it was, well, what if I just got a 64-bit number as a result of a computation, and now I want to use it in my for loop. And so to make that work, there's now range 64, and it just behaves like you would expect it to. So we talked about the Revamped CLI and why that's super cool, and that was the last thing really worth mentioning. If you want to update, you just rerun that install command, and it will install the latest version. At least it should. And also, just to note, in the future, for the next upgrade, there's now the Onyx self-upgrade command. So this is on Linux and Mac, but you can just run self-upgrade, and it will auto-install it. I'm going to scroll through quickly the full changelog, but I don't think there's much else to mention. Right, JavaScript Interop, we got implicit injections. Named return values, actually, that's a small one, but kind of cool. So the idea with named return values is that when you are returning things, you can give them a name, which you could kind of do before, but it didn't do anything. It actually does something now. What it does is it simply defines this as a local variable that you're able to just set. So right, I don't have to declare X, Y, and Z here. I can just assign them. And then when you return, you can do this thing called a naked return or an empty return, and this will return these three local variables. I could overwrite it and say I want to return 1, 2, and 3, and that would work. But if I don't write anything, it will default to returning these three variables. So it's kind of nice. It kind of makes this pattern really useful. This is kind of just an example I was testing, but this is one that's really kind of cool for like summing up a list of numbers. You can just define your total, and this will be 0 initialized. And so, your sum in this case will start at 0. I can loop through all of my array and just add to that total and then just return at the end. You do still have to have the return. If you forget the return, this is a bad example because that's a macro and I don't think it works. It's actually weird. I thought I handled that case, but maybe not. But if you forget the return, you now get this error that says not all code passed return a value. That was something I implemented that should have been there a long time ago, but it's a good win to have it now. So those are kind of just nice. This is actually kind of a useful one to mention. Linux Arch 64 or whatever, ARM builds basically are now supported. They're now released, all three versions, the no runtime, the OVM runtime, and the WASMer runtime. I didn't think that these were going to be super necessary. I don't think many people are running ARM-based Linux and or like Asahi Linux or anything like that. But then as I was setting up projects that I work on this MacBook that I kind of inherited, I realized that if you use Docker and you're installing packages there, it's ARM-based Linux. And so then when I tried to install Onyx, I got an error saying like there's no version for ARch64. I'm like, oh yeah, there wouldn't be. And so I spent a little bit of time and set up the GitHub actions to compile those. And so now those are part of the just standard release. We talked about slices and arrays, the range type. Oh yes, this is also one I just should have mentioned. There's actually a lot of things in this release. Um, there is now a new error format that is not the default, but you can enable it if you would like it. So let's cause some kind of error in here. Let's say I remove this, and so I get this not all code pass return value from the LSP. But if I were to try to run this, it's test named return values, we will get the error in this format. So this is a little bit nicer than the version 1 format. If I were to, I think I just do space v1. So this is what it used to look like, which wasn't bad, but it was just a little clunky. I didn't like that the error was like way out here in the formatting, especially because your name can get really long. And so v2 is more colored and it's more prominent what the actual error is. And if I cause an error that is going to have these little quoted things, what I did is I said anything that's quoted like that is actually going to just appear as a different color. And so now you kind of get these like more highlighted colors about what's going on, which I don't know, I think it's quite nice. I believe that Windows supports error format v2, but I don't think it supports the color, and so I think you get the same thing just without any color differences, which is probably all right. I think I can run with no color. No colors. Yeah, so you get something that looks like this. Same exact thing, just without any of the extra coloring. So that's, again, just kind of moving in the direction of making Onyx feel a little bit better to use. Not much to mention here. Revamped CLI. Yeah. So, check out this new release. I think it's really cool. I want to see what people make with the JavaScript Interop. I'm sure it's missing some stuff. I'm sure it's not perfect, but I want to start speeding up these release cycles. And so if there are issues, I want to get them in, and then I want to get them fixed and switch to a maybe 2-week release cycle. I initially, in the last release, I'm like, I'm going to release something in 6 weeks. And it is 6 weeks later, but I do feel like a lot of time went by, right? I was able to do all of these things just kind of in my spare time. And so I think switching to a 2-week release cycle will be much better. And so hopefully maybe mid-April we'll have another release of some more cool stuff. So I'm excited to see what happens. Check it out. Website and all the links are in the description. And let me know what you think.